All right, so a lot of people are having trouble with understanding potential difference problems, and I think that is a fairly complicated topic and a little bit unintuitive. But if we could just get through some of the basic ideas, then I'm sure we're not going to have any problems with this. Um, so a point charge 5 nanocoulombs is located at the coordinate point 340, while line y equals 1, z equals 1 carries a uniform charge of 2 nanocoulombs per meter. So we want to find A if V0 is equal to V equals 0V at the origin, and we'll find the voltage at A, or find the potential. We could do that, or let's just do B, because I think that one's got a little bit more, a little more to it. So let's just do that. So first, let's just start by drawing our axes, like that, something like that. Now, point charge is located at negative 340, so we're going to have to go back in the x, 4 in the y, 0, so that's right there. So we'll call it P. P for point charge. And then the line y equals 1, z equals 1. So, okay, so we know that we got y is equal to 1, z is equal to 1, so we're going to have a line like this. Right like that. Okay. Okay. So, so we need to figure out what's the voltage at C. Okay. So first of all, we know we're gonna have the voltage, or the potential is gonna equal the voltage from the point plus the voltage from the line, right? Well, how do we find the voltage from the point? Well, that's easy. Remember the formula that we learned. The voltage is equal to negative integral of E dot dl. Okay? So in our case, and remember these are vectors, so the potential is equal to the electric field times the length, or in this case it'll be the radius. So remember our formula for electric field is going to be equal to negative, it's going to be equal to Q, the charge Q, over 4 pi R 4 pi epsilon 0 R squared, and our DL, we'll say our DL would just be, and this is, remember this is going to have our R hat times DL, we could just call this dr times R hat. Okay, so we could see right here that these are just gonna become 1, right? Because the dot product of any unit vector with itself is just the number 1, and so that's going to give us, well, we could take out the constants. We know Q is a constant, 4 pi epsilon 0, and we got negative integral of dr over R squared, and that's just going to equal to negative 1 over R, which is going to be positive because of the negative sign. So we just have it's equal to Q over 4 pi epsilon 0 R, and so that's going to be our voltage from the point, right? So that's not so bad, right? And if you want to know why I didn't do limits, it's because we're just assuming that that we're moving from negative infinity to so it starts at negative infinity and then it comes to the point. So we consider it 0. And if you need me to go over that, I could do that in another video. But I think right for now, this should be fine. So anyway, now we need to find the V of the line, right? So that's going to be a little more challenging, right? Also, I'm going to just choose a different color because it's going to be a lot more challenging. So we know the voltage of the line. So it's the same formula, right? E dot dl. But we have to remember what E is, right? Because we have a line, we have E is equal to the integral of, remember, rho L, the linear density, times dl over, because that is equal to, remember that q, dq, is equal to rho L dl. So we have that, and so that's going to be 4 pi epsilon 0 over r squared. And now, because we're dealing with this as because we're dealing with this Now there's actually two ways we could solve this. We could solve it this way, but we could also solve it a different way. We could use Gauss's law. Because if we know Gauss's law, we could say that we've got the integral L of rho L dl is equal to the surface integral of E times ds is times epsilon 0, as long as we have a constant electric field. So now we know the integral of this, rho L is constant, so it's just going to be rho L times L. And then the integral of this, the surface, we're just going to be creating is basically like a cylinder with open ends because it's infinite length. So it's just going to be E and these really aren't vectors anymore because well, alright, whatever. So this could possibly be times 2 pi rho L. Okay? So we cancel out these L's, and so we got E is going to equal to rho L over 2 pi rho. Okay, and rho, that's our radius. So that's our E, and then if we want to find, so now we can plug that into there. So we could say that VL is equal to the integral of rho L over 2 pi rho times d rho, and then in the rho vector direction. Okay, so that's just going to give us negative rho L over 2 pi. Oh, I forgot the epsilon. Two pi epsilon naught of ln of rho. And if you don't know how I got that, then you should better start studying more calculus because you're going to be freaking screwed. So basically now we have our formula. So we said that V is equal to, I'm just writing this up here, Q, V equals, here I'll just write this in blue again, Q over 4 pi epsilon 0 R minus, I'll put this in green again just for fun, rho L over 2 pi epsilon 0 ln rho And let's not forget this is a constant that we need to remember. So we've got this. So now let's make sure that we go back to the question and look what we need to know. So we got VB. So we could find the difference between the two, right? So we know we could find VB minus VC. Okay. So how are we going to do that? Well, let's think about this. So R of B, well, we know that B is 1, 2, 1, right? So if we find the difference from so if we got from 3, 4, 0, so we're going to minus 1, 2, 1 minus 3, 4, 0. So I'm just gonna, so this is gonna equal, let's see, 1 minus negative 3 is 4, 2 minus 4 is negative 2, and 1 minus 0 is 1. Find the actual value of that. It's going to be 16 plus 4 plus 20, so root 21. Now R of a row of B, I'm going to write this over here so I have more room. So we know that we got, let's see, row of B. So we actually got to figure out we want to have the same x-axis, right? Because remember, we're basically, what we've done is we created like this like thing around it. So at any specific point, row would just be like, this is row, this could be row. Okay, you understand? So at B, we're going to have x is going to be 1. So so the point 1, 1, 1 is the only distance row from B. So we would have, I hope this makes sense. We'd have, let's see, 1, 2, 1 minus 1, 1, 1. So that's going to give us 0, 1, 0, which equals to 1. So let's find R of C. So R of C. So we're going to have C minus 3, 4, 0. So C is negative 2, 5, 3. Minus 3, 4, 0. That's 3 is negative. So that's going to give us, let's see, negative 2 minus 3, so it's 1. 5 minus 4 is 1, 3. So that's going to give us 11. Root 11, I mean. Then row of C. So we know that C is, it's also 2, 5, 3, negative 2, 5, 3. So we're going to minus negative 2, 1, 1. So which will lead us with negative 2, so we'll get 0, 4, 2. So that's going to be 16, 20, so root 20. So that's just going to be the same thing as 2 root 5. Okay, so now we can find our VB minus VC. So we'll say VB. So I'm going to just arbitrarily change colors. Minus VC is going to be, I'm just going to try to make this as neat as possible. We get Q. I'm just going to write the formula Q over 4 pi epsilon 0 1 over RB minus 1 over RC minus rho L 2 pi epsilon 0 ln rho B over rho C. If you don't know how that works, then you obviously don't know shit about math. So now let's just start interacting our numbers. So remember that Q is 5 and rho L is 2. 5 times 10 to the negative 9 over 4 pi epsilon 0 R1 over square root of 21 minus 1 over square root of 11. Minus, when that's 2 times 10 to the negative 9 over 2 pi epsilon 0 ln of 1 over 2 square root of 5 plus C. So we know that, so this, let's just put in our handy dandy calculator. What would be the best calculator for this? I guess the phone, where is that? Do this off the chart. So we got, two. So what I got is I hope this is right. So get VB minus VC is equal to that's what I got. And then so we know that this is 100. All right, so let's just check our book now because I'm obviously very bad at this. So we don't need the C. So now I got the right answer. Oh, okay, so my calculator messed me up. So it's actually 50. And then VC, and since we know VB is 100, then VC is going to equal to equals 49.83 volts. So obviously I do know what I'm talking about. So if anyone doesn't believe me, then they can go kill themselves.